What's up, my fellow PC enthusiasts? Welcome to Computer Tech and More. Today we're going to be taking a look at the Arctic BioniX P120. So let's get right into the graphs and then we'll do open box. This is the basic spec from information about the BioniX P120. It is a little bit thicker than a standard 120mm fan. It's 27 inches as opposed to 25, but that could also be accounted for the rubber pads on it, adding a little bit of extra thickness on it. Fluid dynamic bearing, 12 volt, 0.13 amp, 200 to 2100 RPM, airflow 67 CFM, and H2 at 2.75 millimeters of H2O, and its volume decibel at 16.5, 6-year warranty. Alright, first up is the case flow simulation test. So this test is done in a box that simulates a basic case. It can fit up to a 180mm size fan, and it's taken at 6 inches, 9 inches, 11 inches, and 14 inches. And this is representative of a very small case, a very small form factor, non-traditional format case, a small form factor type case that is more traditional type layout, a compact mid-tower case, sort of like the Fractal Meshify 2, I think is their mid-size. I could be wrong. And then, or like the Corsair 550D would be a pretty good example from way back when. And at 14.5 inches, which is representative of a big case like the Fractal Design Torrent. Vertical axis is the Airspeed. So again, you can look at it in a couple different ways. So whether you have a big case and you need airflow to get to the back, in which case you're looking at which fans are able to push the air effectively to the back of the case. So in that type of situation, you want to be looking at how much does the air dissipate over the distance. So the better fans have very little dissipation, meaning very little slowdown. So the absolute ideal fan in the perfect world would be a perfectly flat line. It would not lose any air velocity over the distance away from it. But we don't live in that sort of ideal world, so you should expect some kind of loss in speed. However, it's how quickly does it lose that velocity and how linear it is. Ideally, you want it as linear as possible. And the other way to look at it is what sort of size case do you have? So if you only need a small case, well, then you're going to be primarily looking over here. If you have a bigger case, you're going to be looking over there. Or like, for example, the Fractal Design Torrent, the fans are all along the bottom, so they're actually blowing air directly into the GPU. So you're actually looking at the 6-inch mark for how effectively it can push air to that short distance. So depending on where you plan on putting the fans is where you'd want to be specifically looking on this type of chart. And specifically on this one, I took it at 20, 40, 60, 80, and 100% RPMs, and the other ones would fit somewhere in between them. But all this doesn't mean anything unless we have something to compare it to. So let's compare it to my control fan. So the control fan is a Noctua A12X25 mixed with a little bit of A14 in there, just because 140mm fans do a little bit better farther away from the fan. They push more air, so they fill the volume better. So even though they may dissipate air in every direction, it's moving enough air that they don't lose as much by the end of the case. So I have a 3/4 A12X25 to 1/4 A14 in this. And then the screen line is representative of the P12. So I want to include another Arctic fan in there, and the Bionic P12 is sort of fundamentally similar to the P12, and then the red line is representative of the Bionic. So we can quickly see that the Bionic is just not doing particularly well. It does okay at the 6-inch mark, but they advertise it as a pressure fan, but its frame doesn't lead me to believe that. We'll get into it in a later section, but let's check it. This is noise normalized to my 40 decibel mark by my readings, with the microphone basically placed right up against the fan blades. In future testing, I am moving away from doing that, and I'm going to have a whole sequence of videos where I've retested everything. But while we're onto this, Now let's take a look at things at 100% PWM signaling. So this is letting the fans run at just maximum, full speed, full tilt, don't care about the noise, just how much air can it move. And you can see that the P12 does pull out a little bit ahead. It does quite well actually towards the end, but they're all fairly similar, and the Bionic pretty much follows my control. Going back to this, so fans that are in this area here should be considered good. So same thing at 100%. Fans over here should be considered good. Fans down here should be considered bad. So they're at the line, so they're be considered good, fine fans. Now, comparing these fans to pretty much every other fan that I have tested. The BioniX P12 sits right here in noise normalized testing. It is darn near the bottom. The other notable notes, this is the S12B. It performed particularly badly. Meanwhile, the P12 is sitting right here, and the P12 Max is sitting pretty much even better. And again, this one is noise normalized values. So if you have a small case, you want to be looking over here. You have a small, medium, large, and you're trying to get air to the back of your case. So again, this is with it free flow, no restrictions, basically a pure case fan type test. Moving on to 100% PWM signaling, the BioniX P120 is sitting right here. So it is effectively middle of the road. Here it is greatly outperforming the S12B, but again, this is letting them run at maximum RPM, maximum noise levels, that kind of jazz. So it's not a perfect test here. Since it's letting the fans run full tilt, and over here on the side, you can see the RPM that they're running at as well as the noise level that was recorded. And again, this is with the microphone basically placed up against the fan. Next up, still in that case airflow testing, we have at the 9-inch mark, case airspeed versus decibels. So this is again at that 9-inch mark. So how much air was it moving for a given noise level? And here's the Bionic right there. So it is sitting towards the bottom of the pack, and this orange line right above it is actually representative of the P12. So the P12 is doing better. So in this graph, getting up here in this direction is better. Basically, you're getting more performance for less sound over in the top left category. So the Arctics are just not doing particularly well with this method of testing. Over here at the top, though, we have the Gentle Typhoon, which did particularly well. Next up are Airspeed through my CPU cooler, and this is the Noctua U12A. It's a single tower twin fan cooler from Noctua. So in this, I feel that it's a reasonable choice for air cooler and quasi radiator because it is a thicker heatsink, and it's got a pretty dense fin stack, so it has a good amount of pressure, but it's not quite as tough as really high quality, like ultra strong radiators that need really high pressure. And it's also not as spread out as a lot of other heat sinks on the market. So this gives you some idea of how a fan would do in a pressure type application. So all that being said, on the left graph over here, we have RPM versus airspeed. On the right graph, we have noise versus airspeed. In both these graphs, the top left corner is what is considered a better fan. So focusing on the left fan first, or left graph first, the blue dots right there, representative of my control fan, so it follows this path. And we can see the Bionic X actually is fairly similar, except not as good at the low end. The P12, which is kind of gray, unfortunately, in this, actually is following a little bit better path. So this would be used for a blade design efficiency. So if you want to compare fan blades for, I don't know, like a channel that does the fan showdown, you could use this to help you design a better fan blade. So it's how efficiently can a particular RPM move air for a design a fan. But that doesn't mean anything unless you're also keeping it silent. So on the other side, we have the noise versus airspeed. So this is noise efficiency. Well, neither of them match the control fan. They're both kind of subpar in this category, with the BioniX X actually being slightly worse, except at higher RPMs. Arctic BioniX X P120. Arctic P12 Bionic. Pull config. So next up, we're going to be taking a look at all the fans compared to a bunch of other ones that I felt were applicable to this to show how things kind of rank out. It's not every fan I've tested, it's just a good cross-section of them. So a couple notable notes on this. Over here, the wattage with a number next to it. Well, that is from another video where I tested out what the maximum cooling potential of my CPU cooler was, the U12A, and what air velocity going through it, meters per second, equated to the rough wattage of my Intel i7 11700K. So note your CPU may differ, even if it's technically the same wattage, just because chip layouts are different. I just want that full disclosure. And also your cooler, if you're not using the same cooler as me, this wattage means nothing. But what it does mean is that if you're looking at these noise normalized results and you have a not as good fan, so let's say something down here, well, for the same noise level, you could be pushing a lot more air, which means jumping to one of these fans up here, you would instantly see better performance on your particular cooler. How much difference in performance, it's hard to say, but you would see some amount of performance improvement. So just for my own particular cooler, approximately 3 meters per second gives 250 watts, 240 watts is 2.46, so around 2 gives around 225 watts of cooling. So we could quickly see that at my noise normalized value, the BioniX X is just kind of underperforming and underwhelming a whole bunch of other fans. So like the T30 did pretty well, and the A12X25 is here at 1.3 at my noise normalized value. And the noise normalized value I came up with was approximately the RPM range for the A12X25 when I had an AIO for my previous system, and basically the noise level that I could barely hear those fans while sitting pretty much next to it. So that's how I came up with that value. Next up, we have the exact same thing, just at 100% PWM fan signaling. So once again, we have the wattages associated with air speeds on it. So even though the T30 and P12 Max are rated at higher than 3 meters per second, I don't actually expect it to go past 250 watts because that appears to be the limit for my particular CPU. So again, depending on what kind of CPU you have, what cooling you're using, you will see differences in how much cooling potential a particular fan can do. But if you're looking at something that's on the bottom of the graph, so like the TLG12, the Arctic P12, and you're jumping up to like a T30 in a F12 3000 RPM fan, or the P12 Max, you're going to see an improvement in performance because you're pushing more air through it. But there is diminishing returns for how much air you can push through a cooler, and seeing meaningful wattage increases and clock speed increases. So the P12, or the BioniX X P12, so that's the Arctic, was spinning at 2,165 RPM and 60 decibels. So that's pretty noisy. It had equivalent performance to the A12X25 through my heatsink. However, you'll notice that there's a big difference in noise value. So moving down the graph, the G12 here has a similar noise level to the BioniX while moving quite a bit less air. The Arctic P12 is sitting a little bit lower Oh, this would be a great opportunity for me to talk about my margin of error because we're looking at a great graph for that. So in Airspeed, my anemometer is plus or minus 1.1 decimal point 1 meter per second. So fans that are 0.8 to 0.9 could be considered functionally equivalent. It's within error. Now, I did do their tests several times and did it through averages, and on average, the P12 just will outperform the P12 down here at 0.8 to 0.9, even though technically it's within margin of error. And on the previous graph, when we take a look at noise, my margin of error in noise values in this method of testing was about 4 decibels. So every 10 decibels is a doubling in noise volume. So that is actually quite a big difference. Unfortunately, it's just the level of hardware I have right now, and it is a limitation that I have, and I'm trying to mitigate it with future testing that I'm upgrading. Although it's viewers like you that will allow me to, by subscribing to this channel and joining my Patreon page, to give me support so that I can acquire basically a better testing microphone, because right now I'm using the one that I'm actually recording my voice on. But let's get back to this graph. So all that being said, so 60 decibels, the ARGB version actually is technically more performant for the same noise value. The Wonder Snail is a lot less noisy. The Ventro Pro, which is the same as the Gentle Typhoon, is up here, 2.2 meters per second. And way at the top, we have like the T30. It has the same noise volume level as the BioniX P120. Same with the P12 Max. So really, for the same noise level, you can get much higher performance with other fans. Next, we're taking a look at, still through the AirCooler, it's airspeed versus decibels. So this same data, just taking a look at it from a different perspective. BioniX P120 is right here. It is sitting at the bottom of the graph. Good fans are over here. So a perfect fan would be over there. It'd make no noise for all the airspeed. But there's the BioniX. It's not particularly great. The yellow is the A12X25, so I did cut off the bottom here because I wanted to be able to zoom in as close as possible. Over here is the P12. So the better fans are sitting over here, which is like the Mobius 120 OC and the Gentle Typhoon. Next up, we're taking a look at CFM. So CFM is sort of interesting. A lot of other reviewers take specific looks at CFM, which is cubic feet per minute. It's a volume of air. It's certainly a valid way to test fans. However, it's important when you're taking a look at it when air is traveling through like a heat sink or a radiator or something like that, because then it's literally pushing air through a channel, and how the air dissipates in every direction doesn't matter. But when you're doing CFM, if you're not, you need to look at CFM with different obstructions in the way. I don't think CFM is very valid if you're looking at it as a case airflow fan, because calculating CFM, you literally have a fan blowing air down a tube. So it doesn't give the air a chance to dissipate in every direction. So if a fan does fling air out to the side, it will reduce its performance, but not to the same extent as doing my case airflow simulation test. So I put it in here just for sake of argument, everybody does it, but I think it's a little bit less of a valid test than some of the other ones that we've done earlier, which is why I put it at the end. Oh, excuse me. Now, all of that said, here we are. We have RPM versus CFM. Good fans are over here. And on the right side, we have noise versus CFM. Noise and CFM, good fans are again over here. So this is a blade efficiency test with my control fan and the BioniX P120. They are very similar in their terms of their blade efficiency, which we did see earlier on with the heatsink test. So go figure. And as for noise performance, we do see that the BioniX is underperforming, so not much difference there. Now we're taking a look at them compared to a bunch of other fans. So this blue bar represents my control fan, and this is noise normalized up first at that 40 decibel reading. we have the A12X25 sitting right here. So you can see that there's quite a big difference currently in this current version of my testing methodology between the General Typhoon, the Mobius 120 OC, and the A12X25, which I found particularly surprising. But right down here towards the bottom is the BioniX P120. It's not the worst performer, but it is towards the bottom. Matter of fact, the P12 is lower than it. But gives you some idea of how it stacks up at my noise normalized testing value. Looking at the same thing again, but this time we're taking a look at it at 100% PWM fan signaling, and the BioniX X does well. Here it actually underperforms against the A12X25, and again it's much noisier, but it's a middle of the roads fan. It's not good, it's not bad. I do find it a little noisy, but you certainly could do worse. So changing things up, just to keep looking at CFM, this is across the RPM or airspeed range. So we have CFM, cubic feet per minute, and the decibel reading. So better fans are still over in this top left area. And we can clearly see that the BioniX X is sitting right here at the bottom, once again proving that it's not particularly noise efficient in this method of testing. So we'll just have to wait and see how it does in the value proposition, which will come up after we do the open box section, which is next, and the blade analysis. So I'll see you there. So we finished going over the graphs. Let's do our open box experience. This is the box that the BioniX comes with. It's got nice vivid colors. This is the red version. It has a variety of different colors. Pressure optimized 120 millimeter gaming fan. PWM PST, that's just the specific feature on the cable. On the back of the box, it has a diagram of their optimized static pressure airflow, diagram of the fan blades, the motor, and some basic spec information. Inside, we get a QR code and some basic screws. Of course, we also get the fan. So now let's go over the fan. So first, I want to talk about the frame on this fan. It has these little joggles on it. So this will not create a perfect pressure seal on your fan when you have a couple of them lined up next to each other. That will allow air to escape. So this already isn't quite as well pressure optimized as they're claiming. Now, it may still do perfectly fine, may still be adequate, but there's just room for air to escape around the fan itself and basically come backwards or out the sides, that sort of thing. Unfortunately, radiator testing is currently out of the scope of my testing capability. It is something I'd like to add in the future through the help of my Patreons and subscribers like you. But anyways, let's continue talking about the frame. So it has little rubber pads, dampeners. It's pretty hard rubber, so I don't think it'll absorb as much as other brands, but it should still do a little bit to help absorb vibrations. On the back, it basically looks identical. It has nice thin struts, and the cable running into the motor is very, very, very well aligned, creating this nice thin little profile so that it's obstructing the airflow as little as possible, so that as much of the air coming out of the fan gets, well, pushed out the back. So that is a very good feature about this fan. The struts have a fairly aerodynamic shape to them, just a basic like a semicircle, I would say, maybe a quarter of a circle. So that's pretty good. As far as the fan blade, well, it looks near and identical visually to the P12. Arctic's just default basic fan that's pretty much in all of their products. It visually looks almost identical. Unfortunately, I don't have one on hand anymore. But the blades are nice and thick, and they've got a fairly steep sweep to them, but the gap between them is fairly large. So they are designed to be pressure optimized, but the gap allows for more air to push through it, leading to a hybrid style design. So it can do pretty well in both airflow and pressure applications. As we saw in my testing, it overall wasn't very good in noise normalized case airflow, but at the 100% RPM speed, it did very well. So that basically means that this is a fairly noisy fan, even though it actually performs fairly well. Unfortunately, the noise comes from the motor itself and how well this part is designed. And some of the noise is actually by the blade design, how essentially noisy they are as air rushes through it. So there could be some optimization that Arctic does in the future there. As far as how it did on my CPU cooler, the U12A, it did fairly well at RPM versus speed was very good, but not noise, or not in its noise profile. So it's just a bit of a noisier fan, which is unfortunate. I think it actually looks quite excellent. I like the accent color that is involved in this fan. So now let's dive deep into this blade profile. So I mentioned that it's very good for its RPM. So that's how much air it pushes for its RPM. And that comes down to the blade design as opposed to the motor. The motor determines how fast it spins. The blade design determines how much air it can move. So the blades are well designed for moving air. And if you're using it in a pull configuration, so hooked up to the back of the heatsink, or at least my particular heatsink, it creates a high-pitched noise. And that comes down to how close the blade tip is to the edge. I just found it to be high-pitched, but not particularly loud, which is good. It means that it can be used in a pull configuration adequately, even though it's not optimized for that. And depending on what you're using it on, it may be better than adequate. So with its blade design, these large gaps, lots of air can get through it. The thicker blades allow for better pressure, and these blades are a scoop style design. I basically say it like that. So flat on the front and then heavily curved to accelerate the air out the back. And it's got a fairly sharp tip on the front. The edge gap between the edge of the frame and the blade is what I'd call in the normal, higher side normal end of the range. So it's adequate. If they got it a little bit closer, it would be better at pushing more air and being better pressure optimized, but it's also more expensive because you have to have a better material for the fan blades, a lot like Noctua's. So that drives up the cost to have the better, more expensive material, because cheaper materials will tend to stretch over time, and when the fan blades stretch, they'll eventually hit the housing and either cause the fan to no longer spin or make a horrible racket as the blades are hitting the edge of the frame. But the cup design of it, again, helps accelerate the air out the back, and it's a steeper cup as you're inside, as opposed to the outside. And that's just to help the inside accelerate more air through it. Since in most fans, actually in all fans, more air is pushed out the edges of the fan than on the inside, which is why it's important for the pressure application. The tips, or front edge, there's you can see a little bit of an angle there, so it has a little bit of a sharp edge to it. It's not particularly sharp, like I'm not going to cut myself. You would get hurt on the tip here if you were stopping it with your finger, but not this inside edge. But it is sharper than a different angle than the rest of the blade. So overall, I really like this blade design. It should do fairly well, but they could do a little bit different with the actual housing of the frame to help with sealing in that pressure so that it would be better optimized in that pressure application for radiators and heat sinks. And working on their motors to make them a little bit quieter, that would be the main things for Arctic. All right, now that we've gone over the fan, let's jump to the value proposition. All right, we just finished taking a look at that open box experience. I hope you enjoyed that. Now we're going to take a look at the value proposition of this fan. So regularly, the BioniX P120 is a $15 fan. However, right now, at time of filming, it is down to $12, which does change its value proposition actually pretty significantly in this price range, because that is a huge jump. But the analysis we have up here is for its original price, the retail price, which I do think is the most valid way to look at it, because all the other fans are based on retail price. But note that if you're on the border for it, a lower price does make it essentially more attractive. But how does it compare to other fans around it? Well, it clearly is on the better side, but it's kind of in the middle. it's not great. The best actually value proposition is the TLG12, and the Antec Storm series are actually very good value proposition. And again, this side is noise normalized. Over here we have 100% PWM fan signaling. So notice that certain fans that may be high up front tend to drop back a little bit once you take a look at things at 100% PWM signal. So it does matter how you're going to run your fans. For case fans, you're probably going to be looking more for noise normalized. For CPU fans, you're going to be probably carrying more about 100% speed. And a mishmash through a radiator, you probably want some of both. But if you're using radiators, you probably got the money to buy the best fans anyways. So anything else I want to say about it? Over here at max speed, it's actually okay. It's actually gained ground. But let's jump to the next one. And the next is at the 11-inch mark. So this is one step away from the end of the case, so it's still middling. And this is where a lot of the fans that aren't good at concentrating their airflow will really drop out. So if you notice over here at 100%, the Storm drops out pretty significantly. And even at the 11-inch mark, they are much lower rated than they were at the 6-inch mark. Mind, the BioniX X has dropped back too, but at 100%, it's doing much better. The G12 is still a top performer, and even is over there. So over here, so then we're taking a look at it. If you have a bigger case, these are the fans you want to be looking more towards. If you have the smaller case, that 6-inch mark is what you care about more. Okay, then what if you want to use it as a CPU cooler or on your radiator? Now we're taking a look at these. So noise normalized, the BioniX X is absolutely terrible. There are just so many better options. The Storm series does particularly well. The G12 is still pretty good. I mean, pretty well up there. The P12 Max is also an excellent choice. Now, at 100% PWM fan signaling, the BioniX X, it has gained quite a lot of ground. It's doing quite a lot better. Once you take noise out of the equation, the G12 has also gained a lot of ground. Actually, no, it did better before. But it's ranked in the top two. But the absolute best is the P12 Max. So, you know, you can look at this for what you need it to be. And last but not least is CFM, and I just want to say that it's okay, kind of top middle, and does okay. So what are these value propositions good for? Well, if you're on an ultra tight budget, you want the best bang for the buck, you want to stare at these 100%. You want to pick out the best fan for your purpose, for your dollar. If you have a mixed budget and you're just trying to decide where to spend your money the most, that's where you try to find the optimal amount of performance for the least amount of money that you can. So you want a bit of better performance, I'm talking noise wise, than let's say the G12. Well, then, you know, you would weigh this with the performance data to pick out which fan works best for you. And if you're on an unlimited budget, well, then you just pick out the best fan for your purposes. So yeah, that's how I think of these graphs in a nutshell. That brings us to the end of this video. There's going to be one quick section after it where I just show the raw data, but I would like to take this opportunity to tell you about my Patreon page. I really appreciate the support that you all provide, and it will allow me to buy better equipment to acquire these fans, do the testing. I hope you're enjoying the content. If there's any fans that you want to see me do in the future, please leave it in the comment section down below. I do spend my time, I do read all the comments, and I try to get back to you with relevant information that you all may have questions about. Other than that, I thank you for watching. Have a great day, and I'll see you next time here on Computer Tech and More. I want to thank you for watching my video on the Arctic P12 BioniX. Please subscribe for more content. I've got lots of fan videos upcoming and already on my channel. If you want to see me review a specific fan, please leave a comment down below, and please check out my Patreon page. I'll see you next time. And right here is the raw data for the Arctic BioniX P120. You are welcome to use this data. You can record it in your own Excel spreadsheets or print it off, whatever you feel like doing. Just note, if you do publish it in a video, I ask that you reference me because I generated this data. I spent many long hours gathering it, organizing it, stuff like that. So if you're wondering, it does take me about an hour and a half to do all my testing. All the data points, and then I have to put it into my Excel spreadsheets, organize it, update the graphs, and then making the PowerPoint for the presentation, and then presenting it. So each one of those other steps is 30 minutes to an hour. So this is a labor of love. I appreciate your watching it. That's just why I want you to reference me, because I put a lot of effort into making this for all you all. But that's it. Thank you. See you next time.